So welcome to video 4 of the introduction, and this is just a test on a particular motor. It's the Orion. You're going to see the name on the sheet anyway, so what does it matter? So what I can do is I can load up, and in my file here I've tested these motors so far. I've got the MCR, I've got the Orion data, and I've got the R1 data as well. And what I've tended to do is I've kept the rollouts the same. So 76, 79, 80.6, and then I do the tyre size, the numbers down here, and then I've got my the timing on the can, just on the can. I haven't got a motorizer, so I can't be specific to exactly what these numbers are. As those of you out there that know, Zen Racing sell a great bit of kit called a motorizer that will give you a definitive idea as to what the timing is actually, rather than what it actually says on the outside of the can. It's the internal sensor board orientation, I think. So these are all the different files that I've created from all the runs that I've done. So what I'm going to do is I'm going to just go through and compare the Orion at so I'm going to load up the rollout at 76.01 and for the 3 different timings. So that's the graph for the first one. That's the graph for the second one, and that's the graph for the third one. So here we have the RPM down at the bottom, and there we have at the top the current draw. Now you can see that at the same rollout but for 3 various timings, there's quite a distinct difference in terms of RPM on the graph. The purple line is the timing at 33 degrees. The yellow line at the bottom is the one at 30 degrees, and the one at the very bottom, the blue one, is at 25 degrees. Now you can say, well, yeah, that's pretty much as we would expect, really. The current draw for the one at 25 is the least amount. It's just down at 10 amps. So again, don't forget, I'm a blind squirrel here, so I'm just I don't really know the ins and outs of all of these numbers. I'm just taking voltage and RPM. In my money, voltage and RPM kind of go hand in hand, and of course the quicker this voltage or this RPM rises up here, for my money, again, I'm very happy to hear from you if I've got this wrong, but if the RPM goes up very quickly, that's telling me that it's going to reach its top speed much quicker. And if I've got a high RPM, the car's going quickly. And if the voltage is down for that, then it's got to be a good thing. So what I'm going to do is I'm going to keep the best one there. So I'm going to keep the one with the most amount of RPM at the quickest time, and the green line, which is this one here in the background, that's the one that's linked with that RPM. So what I can now do is take away the run 1 and run 2, so I can then keep that up. Now what I'm going to do is I'm going to open up the next one. So I'm going to go to 79.11 at 33 degrees timing and load that up. Now what you can see is that the RPM almost identical. Well, they're not almost, they are identical. Then what I want to look at is the current draw. So this top graph here is telling me how much current this is pulling, and the current has gone up, so it's going to get hotter quicker. So that's not so good. I'm going to open up test run 2, and the one that I tested at 80.66 rollout, again the same degrees on the timing. Once again, we're able to see the RPM almost identical again, and the voltage is higher. So we've got absolutely zero bigger bang for our buck, but actually we're pulling more voltage on all of those. So keeping the timing the same and increasing the rollout has actually made the motor work harder, and we've got nothing for it. So this is a classic example of what this dyno can do for me to find out where a good spot on the motor might be. Again, this all has to go down to experimentation on the track now that I've got a ballpark for this motor. How does it feel on the track? What I'll then do is take those two runs away, and so this is the most efficient one. It's giving me the most RPM for the least amount of current draw on this motor. Now what I'm going to do is I'm going to open up what I ran this Sunday at West Kent, and it was 56 degrees timing on the motor and 79.11 rollout. So what I had for the A final against Mark and Luke, I had a RPM at the bottom that's almost identical, but the current that it was pulling was more. So on face value, a motor that was doing really well, that performed well, was actually giving me the same performance, nuts and bolts, but actually is going to make my motor much hotter. Now, over an 8 minute run, which the nationals are in 12 scale, that could mean quite a bit. 5 minutes at West Kent wasn't a problem, no drop off. So quite an interesting set of circumstances that this dyno has given me, made me understand a little bit more about this motor. But again, still to be proven at the track, driving style, etc, etc. But it certainly takes away the fact that I know where the most efficient draw and RPM is for this particular motor, and I think that's worth knowing. Hopefully that's given you an insight into what this can do, and who knows where I'm going to go from here. I think this really just gives you an insight into what this can do, and when I have some more definitive answers as to what gives the best performance, maybe I'll pop back. Well, I won't maybe, I will pop back, and if you've got any thoughts or comments, leave them on the bottom, and I hope to see you all soon at the track.